there is this application I made a few days ago. I'm running it right now on my Windows desktop. So it's just a simple application. I tried using Cubits for it, and I would like to redo the same application, but the views will remain constant. The only thing I'm going to change now is, instead of using Cubits to manage the counter states, I'm going to use bloc just to demonstrate how blocks work. In this case, maybe I can just change this folder to, I can refactor, I can rename this folder to something else. So instead of being called blocks, I can just call it something like the logic. Or so this is the application. You can increment it, you can enable it, and it actually shifts to negative, and you can actually subtract. So this is all the app was doing. So let me see, what was it? Okay, that's okay. Inside logic I can have a new directory, and I'll just call it block. Then under block I'm going to create two files. So I'll just create I'll create a counter qubit, sorry, not a qubit, a counter block. And I'm also going to create, I'll just add it to Git, and I'm also going to create a new switch block. So I'll start with the counter block. First, before we go any further, maybe I can just fix the route here. I'm not working with blocks. I just have to change this to logic, right? And that's what I'm working with at the moment. So it's just, that's the only thing that has to change. And then we have to do the same thing here, change it to logic. And the same thing for this, it has to change to logic. So that's the only that's it with the refactor. So let's jump right into what we really want to do. So I will start with the counter block. Remember what I said in my last video. So in this case, when we have this application in mind that we want to create, we have these areas that the user is going to directly interact with, and those are the areas that we are going to create the blocks for. So in this case, we have the switch and we have the button. So we are going to have two blocks for our interface. And then for this section, the text view, this is just reacting on the user interactions, the two, from the two. So it's just reacting. It's just changing based on the states of the two elements of our UI. So to get an idea of what we want to do, again, the events we might have, and the states we'll be working with. For this button, we know that we have addition and subtraction. So those are the two events that we are going to work with in our application. For this switch, we just have two events. It's either it is enabled or disabled, right? So we can work with those two events. So I'll jump right in and create a simple block for the counter, that is increment. For the block, I'm going to create one on increment and decrement, right? So that's what I'm going to do. So I'll just create a class called counter event, right? This will be the class that is going to be extended by all the events. So I can just create a final class. Let's say counter increment extends counter events. There are some instances where you'll be finding this class has been sealed. just to improve the performance. So we can work with that in this example. So final class counter increment extends counter event, and then we can also implement a second event. We can just call it counter decrement extends counter event. I think we can work with this for now. And then now the next thing we are going to do is create our block. So we are just going to create a counter block which extends block, and you can already get to see the syntax that that block actually expects. So it has two parameters, and the first parameter is normally the type of the event that you'll be dealing with. So in this case, I'll be dealing with the counter event, and then what is the actual type of that counter event? Is it dealing with an integer or whatever? So in this case, I'm going to work with integer, so I'll just put it here, and then I'm going to override the superclass with 0, the value of 0 for a start, and then I'm going to say on, so in this case maybe we can say on a state, instead of just putting it that way, we can specify the state. So for example, on counter increment, we want maybe to emit something. Maybe you can say emit, we want to emit something like the state +1, state +1, and then we can do the same. We can do the same for this one. I think I made a mistake here. This is supposed to be counter block and not counter event. So we can do subtract 1 and just make this a decrement, right? So you can say, in the case of it detects this event, we want it to emit the state subtract 1. So this is what we have for the counter block. The next thing I'm going to do is try and create one for the switch. But for the switch, I don't think we really need to have two events. We can just deal with booleans, right? Though, you know, when you deal with blocks, in this case, it's like you're overdoing it, because block is a little bit heavy compared to qubits. If you see the implementation of this with qubits, it's very light. So the only reason why I'm using blocks is just to teach. Let me just say that it's just to teach. But in the case of switches, mostly you might not really need to use blocks. So I'll just come up with a sealed class and call it maybe switch event, something like that. And then I'm going to come up with one class called switch pressed, something like that, which extends the switch event. That's all you need. And then now we can come up with our block. We can just call it a switch block, which actually extends block, and block takes up two parameters, which is the switch event and the type. In this case, we can just work with the boolean, right? So once we are here, we can import this library by just coming here, import the package, and then we can put this section switch block. Switch block, we can put the constructor there and override the superclass to the value of false, and then we can say on detection of maybe something, let's put an event, switch pressed, right? The moment you detect switch pressed, the only thing you're supposed to do is to emit not state. Let me just put this here, emit not state. And this is the only logic we need for our switch for the block. So let me now integrate this into the UI, and I'll start with here. I'll start from here. So since we are working with blocks, and blocks and Cubits share the same syntax in this section, the only difference will be changing the classes. So this will be counter block. We are working with counter block right now, and in this case we are working with switch block. So that's the only change we'll make in this section. And then let's go to the application widget. Here let's look for the switch. So for the switch, there is something that currently we are using the switch qubit, which is not really the case. So we are supposed to use the switch block. We can put the switch block and a boolean, and then the builder will say the context. We want it to use the state, and then on changed, now this is where the difference arises. This is where the difference normally arises. So we change this to switch block. Let me just put this here, and then we can put dot add, and then we add an event. So which event are we going to deal with? Which event are we going to add to this block? That's what we need to check. So we can check which event are we working with. It is this switch press, right? So I'll just put this event here, and then that's the only thing we need. So at the moment, that's the only logic you need in this section. Now let's try and also change this. For example, in this case we'll be having the counter block, and then we'll just be working with the state of the counter block, and then the last change will be in this section. So we'll be looking at the event of the switch block. So in switch block we are dealing with a boolean value, right? So in case the state is false, then we'll access the counter block and then add an event, add an increment event. So we just say add, and then we can say counter increment, something like that. And then we'll also do the same thing for this section, but instead of counter increment, we can have counter decrement, right? So I'll just come here, and then I can put counter decrement, and this is the only logic that I need for this section. But then everything else will remain the way it is. So I've only changed this from switch qubit to switch block, and since for my block I'm also dealing with a boolean value, I'll just treat the state as so, So I'll say if the state is false, then I want to read, I want to access counter block and then add this event. So the magic with blocks and qubits, and the main difference lies in this section. When you're dealing with blocks, mostly we are based on the user interactions with the application, we are just adding and removing events. That's why that's the main difference between the two. So I'm just going to try and restart the application. It's at 0. When I click on add, it adds. When I click subtract, it subtracts. And this is just the same app, but with a different engine, this time running on block. And that's the only thing you need to do. The first thing I did was come here to multi-block provider. The same syntax remains for this. The only difference is this time I'm injecting my app widget with counter block and switch block. So when I went to counter block, the first thing I did was to change the switch. Looked for switch qubit, replace it with the block, and then how I'm reacting to the user, how I'm reacting to the interaction of the user with the switch. That's different, because in this case I'm pushing an event. When the user presses this switch, push an event. I push an event to this block, so it just detects that this is the event, and so it executes the function that has been quoted, which is emit the opposite of state. We initially we actually put the default value to false. So for a start, it will be adding, but then when you change the state, and it actually matches what we have specified in our button. If it actually matches what we have specified in our button, then you realize that it actually decrements or it increments based on the states. And that's the only logic behind qubits and blocks. Let me know if you have any questions. I think that's it for this video.